Good morning. My name is Sheikh Siraj. I am from EC department C section. Here my roll number is 21951A04J2. So today I am explaining about the ideal black body model historical aspects. First of all we want to know what is a black body. Black body idealized object that absorb all electromagnetic radiation that falls on it. No electromagnetic radiation passes through it and none is reflected. Purpose of this experiment. The purpose of the experiment is to measure the intensity of electromagnetic wave emitted by a black body as its temperature increases, also to use Wein's law to find a max wavelength and use Stephen Boltzmann law to calculate light intensity. What actually happened? Week 1 built fixed flaws in the spectrophotometer. Week 2 read instructions and tried to follow the calibration procedures 2000s. In week 3 finally able to run the experiment with flawed results. Degree of freedom. What is degree of freedom? A set of independent displacements and or rotations that completely describe the change in position of an object. Example practical in three-dimensional space, five possible degrees of freedom. If the practical has structures, three dimension of motion, one dimension of rotation. If particle has structure, dimension, one dimension of vibration. If particle has structure. Average energy. What is average energy? If the temperature of system is known, the average energy in each degree of freedom can be calculated. In 1845, John Watson proposed that each medium of motion shared equally in the kinetic energy of a particle. Here now about equilibration theorem. In 1876, Ludwig Boltzmann proved Watson's theory to be correct. On average, the amount of energy contained in a degree of freedom is equal 1 by 2 kT, where K is Boltzmann is constant and T is the temperature of system in Kelvin. So here UV catastrophe. Not quite right. Problem each frequency of an electromagnetic wave and had a designated degree of freedom. Frequency can increase almost infinitely. Each new frequency providing zero point 0.5 kT worth of energy. Called the UV catastrophes since light with a finite frequency could have almost infinite energy. Everything in the upper frequency would glow. Quantized light energy. What is quantized light energy? Most current and correct solution. Concentrate light to only have certain amounts of energy. I say light can only hold NHF energy where N is a non-negative integer. H is a constant and F is the frequency. This works because HF kg, so it has an example 0.5 kT, 0.0001 HF. However, the energy can only be 0 or 1 and 0.001 is much closer to 0 than 1. Where did H come from? Maxwell Planck's there is a no objectively defined reality out there. The universe seems to require has to interact with it before it can come into being. From pa- paper he wrote in 1900. In this publication, he suggested that there was a relationship between the energy given off by a heated body and the frequency at which it vibrated. Applying H to all of E by M metal box experiment. Here we want to know that metal box experiment assumed that vibration energy was not constant. Light energy instead was made up of a small pieces. Planck called them energy elements. Later they were renamed as quants. From this has were able to develop a formula for the entropy of black body. So this is used for formula to black body. From this formula, Planck was able to discern that expression HV, where H is the Planck constant of proportionals and EV is the frequency. So Wein's law. What is Wein's law? There is an inverse relationship between the wavelength of peak emission of a black body and its temperature. Lambda max B temperature where B Wien's law constant for displacement 2.897768.5 into 10 whole 6 nmk, which is an nanometer into Kelvin. Developed this theory in 1893. Wilhelm Wien observed how a activity containing waves of a light in thermal equilibrium expanded ideally under compression or expansion. The frequency of light and the temperature of the system changed proportionally. Here, what is this? Stephen Boltzmann discovered that the thermal radiation given off by a black body was proportional to the surface temperature raised to the fourth power. Thermal radiation sigma surface temperatures. Sigma is yet another constant of proportionally Stefan Boltzmann's constant. 5 into 67 into 10 plus 8. So here this calculation Winslow temperature and maximum wavelength. So here appearing that the temperature and maximum wavelength. This is the calculation Winslow. Here this light intensity versus an angle. So here we seeing that how it is growing and up drawing graph, and this is a graph of light intensity versus angle. So here also one graph what is supposed to look like. This is look like, see how it is infrared 60 6,000, 5,000, 4,000, 3,000 K wavelength lambda. This here 2.1 point is so here intensity RB. This is the graph of what it's supposed to look like. This is how it's look like suppose. And here also graph light intensity versus wavelength. So you see this how it is. So understand. Now here discussion. Originally could not understand why graphs were flavored. The hopeful futures engineer cannot build a simple experiment that came with instructions. Building Flask added the data studio to ping graphs at 20% light intensity. Other graphs not shown were not even readable. Errors. Many source of error. The presenter substitutions definitions of out of the box broken prism rotations like extra radiation reached the sensor that was not from the block body lamp. So this is about block body, the ideal block body model statistical access. Thank you so much everyone. Thank you.